All right. The nice part about this unit for a lot of folks is this is the last physics unit, and this means this is the last unit that has math in it. Okay? Our last formula that has any math will be in this unit. So the orange card that we've been working with that has math, this is the last thing that has any math in it. So for those of you who've been wanting out of the math, one more formula. The bad part is, those of you who haven't learned how to do the math, this is really our last opportunity till we get to exam review for you to master this before we move on. Okay? So, what is a wave? Where we're going to start. Now, we're going to learn some things about waves. Those of you who had a pretty decent 8th grade experience, a lot of what we're going to do here today and tomorrow is going to be review. Okay? If you had a good 8th grade experience. If you had a crappy 8th grade experience and had sub, what we're going to do is not review. It'll be new for you because you only learned about it in the textbook and you probably don't remember anything you did. But if you had a teacher who actually taught waves and learned how to draw waves and how to label the parts and maybe how to calculate frequency and period in a wave, then it's going to be a review. Okay? But if you didn't have an actual teacher, so you didn't learn how to draw a wave, you didn't learn how to draw the parts, label the parts, and calculate the parts, then it will be review, or won't be a review. You'll have to learn that fresh. So, a wave is basically a traveling disturbance. Now, what's the key word in that definition? It carries what?
Energy.
Carries energy, okay? From place to place. Now, the reason I point out that it carries, oops, I put it in my pocket, that it carries energy from place to place is a lot of people think that it carries matter from place to place. Waves don't carry matter, they carry energy. If they carried matter, if we went to the beach, for example, and waves carried matter every time they came into the beach, eventually the beach would be wiped out. The first row of houses or hotels would be wiped out. The next row would be what? Wiped out. Eventually, Lexington would be waterfront property, and then we would be wiped out. Okay? You would have this constant cycle of whatever's on the beach being wiped out. All that changes about a wave is the what of the wave. The height of the wave changes because the energy of the wave changes. How tall the wave is changes because the energy of the wave changes. Now, the waves come in a little further, and they go out a little further because of something called tides, and that has to do with the moon and the waves, okay? There's a whole section about that y'all should have talked about in earth science, okay? Now, don't ask Miss Wall about that. The last time I had earth science, I was in 7th grade, okay? We didn't take that in 9th grade the way y'all do, and I'm 49 years old, okay? I was in 7th grade when I had earth science, so don't ask me about the moon cycles and expect me to remember how the ocean tides work, okay? I'm a little far removed from that. But my point in this is when waves come into the ocean, students always argue with me and say, no, Ms. Wall, it's matter that comes in. No, it's not. The height of the ocean wave is based on energy. Jacob, put it away, not in your lap where you can grab it again, but away. So when a hurricane comes in, what happens to the height of the wave? Does it get higher or lower? Higher. The waves have more energy. That's why they tell surfers, which never listen, but generally they tell people who are swimming in the ocean to do what? Stay out of the waves or get in the waves? Stay out because of rip currents. You're more likely to drown or have trouble swimming in the waves. All right? Most of us prefer to go to the beach when they're either gentler if you don't swim very well, or maybe they're a little rougher because you like to play in the waves. All right? So they have a little energy, but we don't want to be in the ocean when there's a giant hurricane because they have way too much energy for us to be able to swim and survive. Okay? Now, is a wave matter? What did I just say? No. Okay? The answer is no. It is energy. Waves are energy. They are not matter. Now, we're going to study two kinds of waves over the next week. Okay? The first kind of wave I do every morning when I come to work. I unlock my door, and what's the first thing I do when I unlock the door and open it? That's right. So we're going to study light. The second kind of wave we're going to study, for many of you, is probably the kind of wave y'all get tired of hearing my what? Sound waves, because you get tired of hearing my voice. Okay? So we're going to study sound waves. Now, we're going to learn the official names for light and sound. All right? And I'm going to write them beside these two right now, just so they're linked together in your notes. I'm not going to call them by these names right now, but when you, for those of you who actually do look back, they'll have the names there. Now, light is called transverse. Now, sound has two names. We can call it a compression wave, or we can call it a longitudinal wave. Right? And I will use both names interchangeably so you get used to seeing both names. All right? Well, light waves are called transverse waves, and sound waves we can call compression, or we can call them longitudinal waves. But basically, we're going to study light and sound waves and how they're similar and how they're different. And they've cut back what we have to know about sound waves a lot. We used to have to know about pitch and loudness, but they've cut a lot of that out. So now it's a smaller unit. Everybody have what they need. Okay. So, where do waves get energy from? Does anybody know? All right, put your fingers on your throat. Make a noise. Hum. All right, where does that come from? They come from where? Come from vibrations. All right? Now, I gave you a really fancy answer in red. Jacob's answer was correct. That's an even better place for it. All right? Vibrations is a perfectly legit answer. Okay? The red is a much more fancy science answer. Okay? Your throat was a source. Okay? Any kind of source that makes a noise will cause a medium to vibrate. And we're going to talk a lot about mediums. That's going to be a word that a lot of you are going to look at me like, huh? What did you say? I don't get it. You got to say for him today, you're like Raoul over there with those chips.
I'm trying to get you some energy.
Trying to get some energy. All right. So what is a vibration? Now, we're going to use the word vibration a lot. So what is a vibration?
Vibration.
A vibration.
Oh, that's my
All right. It's a movement. And it has to do something in particular. All right. It has to follow the same path. And it has to follow that same path repeatedly. Okay? So it has to do the same thing over and over and over and over and over again. And it has to do it in the exact same way. Okay? So you follow the same path and you do it repeatedly. Okay? So any movement that follows the same path repeatedly is called a vibration. Now, I'm pretty sure I've got a spot for examples of vibrations. Let's see if I do. All right. So what are some examples of vibrations? Huh? Okay.
Phone buzzing.
Sure. All right, a phone buzzing. Phone buzzing. All right, humming. Oh, that's all I get.
The old TVs.
Sure.
You know how you like go to the TV and like,
I'm old enough to know that sound, but most of your friends are probably not. Say what? Sure, a massage chair.
In the mall, maybe. Same vibration. Yeah. That's why like earthquake. Maybe.
Sure.
Yeah.
you're good.
Oh.
Earthquake's a great one.
Waves.
So just waves in the ocean. Sure.
This thing back here. Whatever this is. Those things. A bell.
That's tuning fork.
A bell.
Hang on, I'll take shorthand.
Instruments. You have to buzz your lips.
All right, you getting the idea?
Alarm clock.
All right, we can probably do this until lunch. We're just not going to. All right? You don't have to think of something so technical like William was straining to come up with old TVs. All right? So unless you've been around an old TV and heard that noise, most of you probably haven't. All right? Then you would have no idea what that sounds like. All right? I'm old enough to have owned one of those old TVs. Okay? My mother still has one. All right? Only because it was her father's and she refuses to part with it. All right? My kids still laugh at it and want to know why we still have it at my mom's. I'm like, just when she dies, we'll just get rid of the TV. Until then, I'm not keeping my grandfather's TV from the early 80s because we bought it when he was dying of cancer. All right, I'm as sentimental as the next person, but I'm not keeping a late 70s, not early 80s TV that no one will ever watch. Okay? It's pointless. All right, aside from the fact that it's like this big and this tall, where am I going to put it? All right, for nobody to watch. Okay? Huh? Outside on the roof. That's a good place for it. Huh? Yes, it is full of crap that my husband owns. All right? I have a garage that I've never parked in. Now, this is the word that's going to drive us nuts. Okay? What is a medium?
A person that can talk to go.
Okay, we need another use. This is one of those science words, okay? In science class, particularly in chemistry class, and physical science class. So we're going to go to chemistry next, right? We're going to use the word precipitate. When I ask you what a precipitate is, y'all are all going to tell me rain, sleet, snow. I know. And I'm going to tell you no. In chemistry class, a precipitate has nothing to do with the weather. Okay? So right now, a medium has nothing to do with people who talk to dead people, ghosts, or anybody else.
Got you.
Okay? Say what?
Something not too big, something not too small. And medium.
Okay. Another use of the word.
Three bears.
These are three bears. All right. A medium is basically a state of matter,
Oh, right.
a wave. Move that W a little closer there. Travels through. All right. A state of matter, a wave travels through. A medium is a state of matter a wave travels through. Make myself a note. Remember that I need to do something. All right. So, what states can waves travel through? They can travel through liquids. Okay? So they can travel through liquids. They can travel through solids and gases. All right? They can travel through all states of matter is where I wanted y'all to go with that. Okay? So, when we have examples of mediums, all right? How much space do I have here? All right? Choose blue. When we're talking, the sound of your voice or the sound of my voice, what state of matter does that travel through? From me to you and you to me traveled through what? Through a gas. It traveled through air. Okay? What liquid did it travel through to get from me to you and you to me? Huh?
Water.
Well, there's not enough water vapor for us to really be overly concerned about. Now, if we were underwater, then yes. If we were in a pool or something like that, then I would argue yes to that. I would not say that there's so much water vapor out here in the air, yes. Now, if we were in the middle of a downpour outside, I might argue yes on that one. But here in this room, I'm going to go no. Okay? But I would say yes to gas. Okay? Now, if we wanted to talk about something being a liquid, how could we have vibrations traveling through a liquid medium? All right, let's not be cooking. How about something y'all would do that would have vibrations traveling through water?
Washing your clothes.
Okay, washing your clothes would certainly do it.
I was gonna say.
All right, you could certainly blow bubbles in the water.
Iced it up. No.
I know y'all didn't actually say that.
Throw something in the water.
Okay.
Skip the rocks.
All right, I was thinking y'all were just swimming in the water myself. Don't y'all go swimming?
I was trying to think outside the box. See, things easy like that don't just come to mind. Y'all ain't
Alright.
harder stuff. Right. Say easy stuff.
All right, skipping rocks. Breeze over here blowing bubbles. Blowing bubbles. And water. All right, so our medium would be what? What's our medium? The water. So our medium is a liquid that time. Now, can I have a medium as a solid?
Yes.
Yeah. Okay. When you're walking, I don't know how softly you guys walk in the house, but I swear when I'm sitting in the chair, my son is like a herd of elephants. I'm like, dude, I feel the entire floor shake. My house, I think, is going to fall apart some days. All right? I don't know how y'all manage to walk from one end of the house to the other, but he's like a herd of elephants. All right?
Nah, that sounds like that. Nobody managed you. In your room here.
And maybe he is, because I asked him to do something. Look,
Hey,
all the way through the house.
At least when you're a little bit hungry to hear that.
All right? So the floor would be a solid. Now, which types of waves need mediums?
Oh.
All right? I want you to think in terms of light and sound. Okay? Does light need a solid, a liquid, or a gas to travel from one place to another? No. Okay? Does sound waves need a medium to travel from one place to another?
No.
Yes. Okay? Sound waves must have a medium.
So can you hear?
Okay? So if I sent you to outer space, is there a medium in outer space?
No.
The answer is no. There's no medium in outer space. So all we would see is your mouth move and there'd be no what?
Sound.
No sound, because there's nothing to create the vibrations. Okay? You have to have something to create the vibrations. If there's no vibrations, there's no sound.
So
Light does not have to have that vibration in order to travel. They travel by something called an electromagnetic wave that we're going to learn about in a few days after Thanksgiving. Okay? The light doesn't have to have those vibrations. Sound has to have the vibration. William, what were you going to say? Okay. Now, let's see if we can finish this slide. Which kind of waves do not need a medium? Light does not need a medium. And if I'm where I think I am, we're stopping. And I am. Okay, light does not need a medium. Sound has to have a medium. And I'm where I was hoping I would be. Now, the rest of what I wanted to get to today, we're going to save for tomorrow. Because that's, how many of y'all remember things like amplitude, wavelength, and frequency? Anybody remember how to do any of that stuff? Okay? Yeah. That's the part that I said if you had a good 8th grade experience, you would remember it. If you didn't, it'll be new. You'd have a teacher. It's okay. We'll learn it tomorrow.
I would be here.
Shocking. I know, it's a little shady. Now, it looks like nobody took a calculator, wise people that you are. Alright? If you're not going to be here tomorrow and you're going to be Alizé and taking your Thanksgiving break early,